This evening I'm having a look at this cassette player very kindly sent to me by Cody's, who is another YouTuber, and he sent me this cassette player. I don't know if you've seen Cody's channel. He does a lot of restoration on particularly Roberts radios, but also sort of fan heaters and things like that. He loves sort of like restoring old heaters and things with sort of nice louvers on them and things. He's particularly keen on. He's just done one recently that I think he's going to launch and then show a video on. But this is the cassette player he sent me, along with some other parts, and thank you for that, Paul. I appreciate it very much. This old Ferguson cassette player is in lovely condition. It doesn't look like it's had a lot of use. So I'm just going to try it this evening to see if it works and see what it sounds like, and just give it a restore. I think it deserves it. I mean, it's in such nice condition. So I've got it plugged in onto on the wall socket here. I've just chucked a little cassette in here, a little TDK D90 basic low quality cassette, just to sort of like a sacrificial cassette, if you like, to see if it works. So it's got a main supply input on the side here, 240 volts. We've got various jacks on the side for record playback, 5-pin DIN, earphone, and the traditional sort of microphone with a remote switch that they used to have on the side of them. So it'll obviously do microphone recording, and you've got basic in ear. I'm not sure if that's probably loudspeaker line. I don't think there's a dropper resistor in series. Battery command underneath, that's in lovely condition. This really, to me, looks like it hasn't been used. It's in really nice condition. Label on the bottom says it's made by Thorn. It's a model 3 T07, and it says London, England. I don't know if it's actually made in London, England. I doubt it's probably made in Taiwan or something, but not necessarily. Warning label on the back to, don't leave batteries in it. And he's obviously won it at an auction somewhere. And lovely condition. Little tape counter on the top. Something nice, these iconic sort of like piano keys. Condenser microphone. Here we go. Made in Korea. There you go. Yeah, they're not usually made in the UK, even at this sort of era. Oh, that button does. That's interesting. What's it say? Hang on. It says push. Okay, I pushed it. Oh yeah. Oh, I know what that does. That must release this handle. Oh, that's good, isn't it? So it's got removable handles. That's quite cute. So there you go. The volume controls on the front. Turn the volume on the front, slider controls as were the Rage in the sort of the early 80s. Lovely condition. So let's power it up and see what it does. So standard sort of like figure 8 IEC lead. Plug it in and press play, and nothing. Fast forward. No sound at all. Can anyone hear anything? Precisely, no one can hear anything. And do you know why you can't hear anything? Because there are no sounds to hear. Sorry, that's a line out of a Red Dwarf, comical Red Dwarf series. Okay, so let's we need to get it apart really. Have a look inside, see what's going on. It might be something simple like the transformers not working. It could be the changeover switch in here, or it could be something a bit more. Maybe a power supply fault, maybe a rectifier's gone or something. Oh, and it ejects the tape, okay. Alright, so let's take this apart, have a look, and see what's going on. Right, so let's see what involves taking it apart. It's usually got a couple of positives on the bottom, I should think. 1, 2, there's one at the back there, that looks like it. So let's whip the bottom off, let's see what we get. Easy enough, isn't it? Okay, so that's the bottom of it, and we're greeted with, zoom in a bit so you can see, we've got a series mains fuse here by the looks of it. Well, certainly a fuse. Here's our main transformer, Belts and all that sort of thing look in good condition. They're a bit loose, but I think they're okay. And obviously this is the main amplifier, and that looks like the long bit along there looks like that's a record playback switch. So the first thing to do, I suppose, is to check the fuse to see if the fuse has actually got continuity. And if it has, then we need to do a bit of further investigation. I think the first investigation we'll do, if the continuity is good on the fuse, we'll check it on battery supply, which just means hooking it up to an external power supply. If it works then we need to investigate further on the switch at the top here, which is the one that switch. This is the switch. When you plug in the mains lead, it turns it over from the DC supply over to the transformer supply, and when you disconnect it, obviously it reverts it back to the battery connection. That's so when you plug it into mains, you're not backfeeding mains voltage into the batteries, which would have been non-rechargeables in the day, and would have just been sort of like normal carbon batteries. There's an inspection label on the bottom here, and a K12/01, and it looks like serial number 7878. I don't think that's anything to do with year of manufacturer. I think it's probably a little bit later than that. But alright, let's get the multimeter out and check the fuse. Okay, simple enough test. Got the multimeter here on continuity across the fuse. Nothing. Okay, so alright, we will replace the fuse, but the question is, why has the fuse blown? It could be a capacitor sort of gone leaky in the power supply, and it's pulling everything down. It could be a number of things, but let's pop the fuse out and have a look at it. So it's a 20mm fuse, and let's have a look at it. Can't see what it says on it because I've got my magnifiers on because my eyes are so bad, but I think it's probably like 100 milliamp or so, probably 500 milliamp. Definitely blown. And what can actually happen, believe it or not, with these sort of fuses, it's 400 milliamps. Probably haven't got a 400 milliamp fuse, but I've certainly got half an amp. What can happen with these fuses, if the fuse doesn't look like it's gone black and a piece of equipment's quite old, you can almost change the fuse out and you might find it will work again. Fuses, because they handle inrush currents, that if it's been plugged in sort of over the years, sort of 100, 200 times, it can actually fatigue the fuse. And even though there's no fault with the actual piece of equipment, the fuse can fail. And the fuse actually usually looks if that situation has happened, the fuse looks fine. Apart from it looks like obviously it's open circuit, but it hasn't gone black or silver like they do sometimes, and that's usually a sign that possibly the fuse has just suffered fatigue. Probably could have done with an anti-surge fuse or something like that. So let's get another fuse in there, power it up, or maybe actually what we should do, probably be a better idea, is to actually stick an ammeter in series with it and see how much current we got going through. Obviously it said 400 milliamps. If we've got any more than that, we've got a problem. So yeah, I think I'll set up a series ammeter and we'll have a look, see what the current's going through. Okay, so what I've done is I've wired this ammeter in series with the fuse. We're not expecting more than probably a couple of hundred milliamps just to switch it on. So I'm going to plug the mains in, and anything more than sort of like 200 or 300 milliamps, and there's probably a fault with it. So let's plug it in and see what happens. So reach around, plug it in. Okay, there's a small inrush of current, but very little. Press play. 3 milliamps. Nothing's happening. Okay, let's try and fast forward. Nope, nothing. Okay, so I'm just going to try it on, just make sure my fuse hasn't blown on my meter. I'm just going to bypass the, we're on 8 DC amps, that would help. Okay, we have got lots of current flowing. Let's try it on 10 amps. Got an amp flowing. So there is something wrong. There's a short circuit on the secondary of the transformer. So it's blown the fuse for a reason. Let's just see to make sure it hasn't blown the fuse because the motor's seized, which is possible. So the amplifiers, the thing's not turned on yet. We've got 20 milliamps quiescent current, which is a lot. And as soon as I try and fast forward it, it draws a lot of current. I can't hear any sounds of an amplifier there. Let's try it again. Okay, so we are drawing too much current for some reason. We need to investigate that. Let's have a quick check on the front end of the power supply, just so we can see anything obvious, because obviously it's drawing an amp, so it's pretty low resistance. That's probably all this transformer can produce into a short circuit, so I'm expecting a sort of like a 0 ohm short somewhere. So we've got the two rectifiers down here. Let's see that, try and zoom in so you can see. Difficult to try and keep everything in view. I want you to see the meter as well so you can see what I'm doing. We've got two silicon rectifiers here, which is, you can't see them, where are they? Just there, yeah, you can just about see them there. So these are the two half-wave rectifiers for the, takes the transformer, rectifies the supply, and then we'll smoothen it. So check those two diodes first, just with the diode tester of the multimeter. See if we've got any a shorted diode. That's what you'd expect. So let's have a look. So we've got cathode in one end, and it looks like the other goes to there. Okay, there's a diode junction, 700 millivolts, which you'd expect. And here, yeah, diodes are okay. So it ain't the diodes. So the next step will be the smoothing capacitor, and I know you can see that as well. It's very difficult to see the stuff here, I know, sorry about this. But there's what looks like quite a large smoothing capacitor just underneath the printed circuit board here. And I'm going to check across there just to see if we've got a low resistance. So this is, I think it's the negative, it's this way, and the positive is that way. Ah. Well, that doesn't look good if you look at the meter. Try and get it so you don't get any reflection, which is almost impossible. Okay, so we're getting looks like a short there. Ohms, dead short. Got a dead short across, not necessarily the capacitor, but it looks like the output of the rectifier to the next stage is dead short circuit. And I am suspicious of that electrolytic capacitor, so the next stage is to try and get the capacitor out of circuit and check again for the short, see if it's cleared. Okay, I've got to take the whole sort of chassis out of the cassette player. I removed the top cover. Now basically all you do on that is you pull it back and it unclips. Now don't force them, you know, if they don't come out like that, there's a different mechanism of removing the top cassette cover, but on this particular one I had a look underneath. There's no obvious clips or anything, so I just pulled it and it just popped out. So I need to remove the 4 screws now that hold the machine basically into the top part of the cassette mechanism or the cassette player. So we've got 4 screws here. Undo that. Now in theory, with a bit of coaxing, once I've got all the screws, oh, is it 4 screws or 5 screws? It might be 5 screws actually. Let's have a look. Yeah, it's definitely 4. Remove those 4 screws. I need a lot of magnet really to pull them out. Just be careful when you're using magnets in the vicinity of cassette players. Obviously, it's you don't want to get it too close to the tape path because you don't want to magnetise anything. I'm going to demagnetise the heads once it's working anyway, but just pull the screws out. Just tip it over and try and get this cassette player mechanism out, which is going to be interesting. Trying to see how it's held in. Some of them are quite obvious, but this one isn't that obvious how it's secured. So, alright, let me try and work out how this comes apart and I'll come back to you. Alright, this thing's a bit of a pig to get to. I've loosened the top screws where the cassette goes in, and it allows me to get a bit of movement to actually lift the whole mechanism apart. And you can see this. There we go, you can see the back's coming apart. And that gives me enough room to get the 2 screws here that allows me to pull the board up. But these are clearly not designed to be serviced, and all the wires are very tight. You can see all these wires here go up to the tape play and record playback heads, and there's, I think that's the microphone input. All these wires are very tight, and what I need to do is I need to get to, you can see that, yeah, you can just see it now. Let me just zoom in. This is the capacitor here. You see that blue circle in the centre of the display? That's the an electrolytic, which I was suspicious of. So let's remove the belt. So we've got the belt out of the way. Now what I'm going to do is try and unsolder the capacitor here. Funny enough, all these caps say they're Rubicons. Now, I'm surprised if it's made in Korea they're Rubicons, but I doubt they were fake in this day and age. So let's get this capacitor out and check it on the meter again, see if this is the problem. So just get my pliers in here and just try and get this capacitor out. Difficult, I know, and I know my hands are in the way. It's very tricky to does it come out, or was it just the pliers slipped? No, the pliers just slipped off. Try again. Come out that time. So all I'm interested in is getting this capacitor out for starts to see if that's the problem. And if not, I'm going to have to unsolder everything, and I really don't want to do that. Okay, that's one. I think that's one leg of the capacitor out. Yeah. So that. Let's measure it now. So let's get you back into view of the multimeter, which you can see there. So we're looking for that short. See if the short's cleared. Hasn't. Short is still there. Okay, so it's not the capacitor on it. It doesn't look, unless I haven't disconnected it completely. Okay, no, that's definitely, that capacitor is definitely disconnected, and the short still remains. So it's something else. So I think I'm going to have to try and get this board apart. Right, what I've done is I'm trying to work out where this short is. I've got a short still across the incoming supply. There's the electrolytic that's come out, and it's fine, no problem at all. But still got a short across this input. Now what I've done is I've broken the track here. I've cut the track. A bit of a bodger's trick, but if you break the track, it means you isolate part of the circuit, and this all goes to the amplifier stage. I've broken this track, but I've still got the short. Okay. So that suggests that this part of the track isn't the problem. There's a short going back up here. Now all I can see this goes to is the the remote control for the microphone, and it doesn't look like it goes to a lot else. I've checked along here, there's no other shorts. So investigating around this area, also looking for sort of like solder splashes across the board and things like that. But I'm expecting a failed component, like a faulty capacitor or something, but so far I haven't found anything. So I'm going to reinstate this track here just by scraping off the solder resist, and the solder resist is green stuff. Scrape this off, reflow the joint, so I've got that connection back, and start looking further up to the left side of the board, up out of your view around here. And this is where the track goes. It goes up here, up around here. It goes to it looks like this point here. Doesn't look like it goes any further. So it could be a short. It could be a faulty. It could be a faulty jack. 2.5mm remote jack, I suppose, shorted to ground. That is always possible. Someone stuck something in there and has damaged it and is shorting it out. But let's get this track repaired and see if we can fix that. Now, that's fairly straightforward to do. What I've just got to do is scrape off the solder resist with a sharp scalpel. That's what I'm doing now. And then simply, once the joint's clean, reflow it with a soldering iron and make sure the solder is flown properly. If it doesn't, you can always put a little tin copper link across there, but I'm too lazy for that, so I'm just going to try and get it to flow across. Might have to put a bit of flux on here to get this to flow. Right, let's try that, see if it's got continuity. If it hasn't, I'll put a link in. So it goes to there and there. Okay, so we haven't got continuity. Oh yes, we have. So we've got, yeah, the link's back in. So let's investigate further up the track and see if we can find anything there. Right, I'm a bit of a wild goose chase, but still had the short on across this where the capacitor was. So I broke the track, as you saw, one side. That didn't clear the short. Broke the track the other side. That didn't clear the short. So I'm thinking, well, there's nothing else connected to the board. There must be a short on the board. Then I looked underneath, and there's a wire here that was connected to the positive side, and that goes to the motor. So it looks like the motor's got a short. Okay, so what I'm going to do now is reinstate all the connections back that I've cut, and then we're going to get this motor apart, and it's probably got an inbuilt servo system inside, so we can hopefully get this motor apart, have a look, see if the motor's a problem, and with a bit of luck we can fix that. Okay, sure enough, here's the motor, and there's a short across the motor quite clearly. So yeah, now we've got to investigate what's wrong with the motor. Now it's possible that these little ceramic filter caps have failed. It looks a bit dodgy here. I don't think anything's shorting to chassis. Let's pry these up and try it again. I don't think that's the problem. Still got a short. Okay, so the next step will be to try and take this motor apart, but I think the first thing to do is obviously disconnect the wiring and get those caps off, and then check again, see if the short's cleared. I'll remove the filter cap, so basically bear in mind that the white wire is disconnected, so these wires are isolated totally. So if there's a short still, there's a short on the motor. Let's look, see what we've got. Now at this point, if there's a short on the motor, what I'm going to do, just to confirm it is actually a short and just not a low resistance, I will actually try and power the motor up. Still showing 0 ohms. Just check on resistance range. Yep, dead short on the motor. Okay, so I think the next thing I'm going to do is going to apply some power to it just to see what's actually going on. This motor doesn't look like this is just a mount that mounts the motor on like an isolation platform. It doesn't look like it's going to come apart very easily, and that's a shame because it's a nice little cassette deck. This I want to get it going now. So it's going to apply a bit of power to the motor. Obviously got more current capability than the power supply inside hand. We could see if we can clear the short and just see if it actually runs, or if it's just like a low resistance motor. It might just be a low resistance motor that's actually fine. It might not actually be a short, but it definitely appears like there is a short circuit on this motor. Okay, I've got the top of the motor mount off. I can't see anything that suggests it will dismantle. Now it's an Orion motor. I've come across these before, and a lot of the cassette decks used to have this era. And from what I remember, this is like a centrifugal regulator on here. Basically, it's when it gets to a certain speed, it will break the contacts, and it's just a momentary break, and then it's just basically like a governor on an engine. So the motor is still like on and offing all the time, but it's dampened up by the capstan's flywheel, so therefore you don't get any sort of noticeable flutter on the cassette deck of this sort of standard. So I've got a funny feeling that possibly the centrifugal system is packed up. There might be an internal capacitor in here that's gone short, but I mean I've tried applying 2 amps onto it, and it's still short circuit. It hasn't cleared the short. Not sure what else I can really do apart from try and take the motor apart, but there's definitely a short with this motor, and this is the problem, which is such a shame. And it's probably failed at quite an early stage actually. Can't see any obvious way of taking it apart. There's 2 screws here, the threads of the screws that have gone through from the other side. Actually thinking about it now, from memory, if I take this cover off, I think there might be 3 little screws on the side where the top of the motor will slide off. It's a do or die on this, basically the cassette deck's had it without the motor. So let's try and get this cassette motor apart and see if we can work out what's shorted on it. Okay, here's the problem. This brush holder here has come loose and it's just floating about in the wind. The other brush has jammed against the chassis and is shorting, causing short that we saw. That's the positive side, goes to the ground, so that's just shorted dead short. We've got a series inductor here, which is obviously just for noise filtering, and then the rest of it all looks fairly okay, but I don't understand why that brush has got jammed behind there like that. That should be sticking out in the middle. Both these brushes should be sort of basically almost in contact with each other in this position, but they're clearly not, so there's something wrong here. This is the other side of the motor. This is the commutator. That all looks fine. It spins nice and freely. And you can see in that gap there, not very clearly, but there's the regulator, the centrifugal governor regulators in there. Appears to be okay. So let's try and correct this and see if we can clear the short and get the motor running. Okay, I think that's fixed now. I've tightened this screw up and that's bent this carbon brush back into position. I've glued this one back in because it had an isolated plastic screw. I haven't got any plastic screws, but I've glued that onto the Paxlin or what is this fibre back washer, and that's solid. So that should be fine. The brush is in the correct position. They should be clear as short. So the next thing to do is to stick it back into the motor and get it realigned in the correct position. See if the motor actually runs and the short's cleared. Okay, just before I do that, let me just show you the motor section. Zoom out a bit so we get a bit of focus. So this is the motor, the armature. This is the centrifugal regulator here, and you can see these contacts here. And basically that swings out on this weight here. You see the weight, the mass that swings out, breaks the contact, the motor slows down, and as the motor slows down, obviously it closes back, makes the contact, and that's basically your speed regulation on a sort of like a budget cassette deck like this. Clever system, and that little resistor's there just to reduce the sort of the arcing that forms across the contacts as they open and close, reduces noise. But yeah, that's the regulator circuit on a budget cassette deck, centrifugal operated. Interesting, clever little system. Really works faultlessly, really, on a budget cassette deck. Wouldn't expect it to see on a hi-fi cassette deck, but on a portable cassette deck, yep, perfectly adequate. That's the motor back together. Short's cleared. The motor spins. I hope it's running at the right speed. I hope it's regulating. A little bit sort of suspect where all these connections go. Obviously, that was soldered to the chassis before this. These were just sort of floating in the air. This is the supply. That's the supply via before the inductor, and that's after the inductor. So I'm going to go from there to the ground, plug it in, and see what it does. Well, it's back together. I'm running on AC supply. There's something wrong with the. I don't know if I've damaged one of the rectifiers. Are damaged from the short circuit, but if you listen to this tone that was playing a second ago, just bear with me. Notice the pitch changes as I turn the volume up. So we got a severe power supply sag somewhere. There's no mains hum, so I don't think it's the capacitors. You listen there. There's no hum at all. So it seems to me that when it's running on AC supply, I mean, they must admit the transformer's output is only about 3.8 volts RMS. And it's supposed to be, I think it's supposed to be sort of 6 volts DC. After rectification, it's going to come up a bit, but it seems a bit low. So need to investigate that. Possibly an open circuit diode in the rectifier. It's not easy to see where the rectifier is. It's sort of, there's 4 diodes on the board that all crammed together, and you can't easily get the board apart. But let's have another look, see if we can see what's going on, because that's serious. That's a big drop in speed with volume. So that's a very saggy power supply. Okay, it's back together again. What it was, there was a wrong connection made from the transformer to one of the rectifiers. I was only using half of the bridge, so we're losing we're only rectifying half the waveform basically. So the voltage was low, and therefore that's why when you turned it up, it all sagged away. The motor didn't have enough voltage, and the amplifier was distorted because not enough voltage on the power supply. So it's running now. and it sounds okay, I suppose, for a portable cassette player. Not brilliant. I'm going to go through, clean the heads, and do the azimuth on a reference tape, and hopefully it will sound a slightly bit better. Obviously demagnetize the heads as well. A bit of a blast from the past, isn't it? I bet a lot of kids remember having one of these at the side of their bed. You know, certainly if you're my sort of age, you will remember sort of cassette players being bought by parents, bought you one maybe for Christmas, and had one of these at the side of the bed, and you used to record Top of the Pops and Pick of the Pops and all that sort of thing. So yeah, they got a bit of a sort of soft spot in my heart, and obviously people of my age, you know, they've all remember these sort of old cassette decks by the side of their bed. Anyway, let's have a little tweak so we can make it sound any better, and then we'll wrap it up. Okay, I've just finished doing a tape head demagnetizing session on it. You saw that in the previous video, so I'm not going to go through that again. Having a look at the heads and the pinch roll, I've taken the top cover of the cassette player off so you can actually see stuff properly. You can see a pinch roll looks fairly clean. Bit of dirt on it, I'm going to clean that. There's our record playback head, the head in the centre of the screen, and that's nice and clean, and there's no wear on it. There is maybe a bit of dirt on there, but not a lot. That white thing sticking out there is the auto stop tension detector. When the tape becomes tight, it pushes on that little nylon spigot thing and turns the cassette player off. And that head on the right with the lettering on it is the erase head. That's all that head does is erase. So basically, when you erase a tape or you record a new track, it erases the track before it comes to record playback, so you don't have sort of sound on sound sort of thing. So let's just see if that actual auto stop mechanism works. So we give that a little poke, and that should just, there you go, looks like that works. So yeah, those auto stops worked in play mode, but they wouldn't work in rewind mode, because when it's in rewind the heads are back anyway, so they're not actually touching the tape. Later decks are far more sort of elaborate and had all sorts of things like that, mechanical mechanisms to detect the spools have stopped turning around and drop the mechanism out. There are also even more elaborate ones with current detection, where they saw a current spike on the motor, they dropped the power supply off, and they thought, you know, the end of the tape has arrived. So let's clean these heads up, and then we'll have a little tweak with the azimuth, see if we can get the sound a little bit better than it is. Okay, that's about the best we're going to get it. The adjustment's very difficult to get. It's behind the chassis, so you have to take the whole thing apart to adjust the head alignment. Sounds okay. Not designed to be high fidelity. It's just a player. You know, it's very, very simple. But it's working well. It's in good condition. The heads are in excellent condition, and mechanically it seems to be pretty fine as well. Anyway, all it takes for me now is just to pop the top cover back on, and that's it, really, the job's done.